Confidence intervals, we're doing some examples, and we're doing cases where we've got confidence intervals and sample means and sample standard deviations. And look, we're going to call this tech active, but there's still going to be a few by hand verifications here. So there'll be some by hand calculations, but we're going to showcase the use of technology here too. We have here the heights of some samples of Army Reserve personnel from there's two divisions, Div 1 and Div 2, and you can see the summary stats there. We got sample size, which we can call n, lowercase n. The mean height, that's the sample mean, not the population mean. And the sample standard deviation, which has the symbol lowercase s. Okay, so soak that up, and then you'll be ready for the question we're going to do below based on that. We're going to do two things. First thing, we're going to determine the 95% confidence interval for Division 1. Okay. Now, if you had to do this by hand, you would know that the confidence interval based on the sample mean is the mean plus or minus the margin of error. Okay, so you know the Z times S over root N as the margin of errors. Sometimes it's abbreviated as ME or just capital E. And for this case here, we have our confidence intervals. Okay, so subbing in and crunching that for the upper end, we get 176.506, the 3 decimal places, or 508. And then we have 174.492, I get. And using technology, we should get the same confidence intervals. So the confidence intervals in parentheses there. Let's have a look at the TI Inspire application. So we've added a page and we hit menu, and so menu and statistics number 6, and then confidence intervals 6 again, and Z interval 1, and we're working with statistics, and click OK. So I know that's an S. We were using sample standard deviation, that comes up as sigma, however, on this here, and we put our 4.6 in. Okay. Then we go down and into the next field, we put our 175.5 in for the sample mean, and we have a 80 sample size. We're already on 0.95 confidence interval, and we get 174.492 and 176.508, which matches what we got last time. Okay, the second of two parts. Now, with we're dealing with the second division, Division 2 now, different data, and their confidence interval is given to us. Instead of calculating it, we have it given. And we've basically using that data from just above there, so just a refresher in the maroon, sample 71, mean height 177.1, and a standard deviation of 5.2. So looking at what we've got here, we have to determine the confidence level as a percentage that was used to calculate this. So something a little bit different. So what we need to do is realize that the margin of error, so we've got X plus or minus the margin of error, is important here. So what you do is grab one of the limits. I'm going to grab the upper limit. You could do this with the lower limit, and it'd be the mean plus that equals the upper end. And so if we rearrange that, so to get the margin of error at based on what we've got at the upper end, we've got 177.891, take the mean of 177.1, and we get 0.791 if we take it to 3 decimal places. Okay, now the margin of error 0.791 is related to our confidence interval formula, and so the margin of error part is Z times S, I'll write it in, over root N, which we have we don't have the Z quantile, alright, that's what we're trying to find. Well, that's on the way to what we're trying to find. But we do have S, and S is 5.2 from the table above, and N is 71, so it's square root of 71. So rearranging that to get the quantile, which sends us on our way, we can find by doing a bit of rearranging, so it'd be 0.791. What you would do in the calculator, 7.791 divided by 5.2 over root 71. All of that in brackets there. Okay, so you would then get, I'm going to use all the decimal places my calculator has given me there. Okay, so that's our quantile, our z-score above and below. All right, so that's above and below the sample mean. What is a confidence level as a percentage? Well, it's related to the area under the graph, and so we need to find the probability such that negative 1.28175 is less than or equal to Z, which is less than or equal to positive 1.28175. Now we can do that on our calculator, our TI Inspire. So we go in and we hit menu, and it doesn't matter whether we hit statistics or probability. I'm going to hit probability, distributions. We're looking for normal CDF based on your previous work you've done, and we've got our lower boundary was negative 1.28175. Upper limit is the positive of that, the polar opposite. Okay, and it's a standard distribution, so we leave mu 0 and sigma 1. Alright, standardized. Okay, now we come out as 0.80007. So correct to 0.1 decimal percent, 0.1% I should say, we get 80%, alright, 80.0. So it looks like they've used an 80% confidence level. Alright, so not a standard one, not the usual 95, not 90 or not even 99, okay, but they've used a different one. So graphically you might recall it looks like that. Okay, I couldn't put that final decimal place in. You'll notice that the upper and lower limits have been rounded, but you can see that pretty much the same deal there. Okay, and that's our distribution there, so the confidence interval graph there.